Do forces always result in motion? Or if an object is at rest, does this mean there are no forces acting on it? In this video, we will differentiate between balanced and unbalanced forces. We will also describe what happens to the object's state of motion when the forces are balanced and unbalanced. To start with, let's recall the simple definition of force. Force is defined as a push or a pull. It is commonly expressed in Newton, in honor of Sir Isaac Newton. Force is a vector quantity, which means it has both magnitude and direction. For example, this diagram showing a 10 Newton force acting on a ball. The force is represented by an arrow. The direction of the arrow indicates the direction of the force, while the length of the arrow represents the relative magnitude of the force. Now let's first consider the forces acting on stationary objects, such as this book resting on a tabletop. While this book is not moving on the table, are there forces acting on it? Yes, there are. There are two forces acting on the book. One force is the Earth's gravitational pull, which exerts a downward force on the book. The other force, the push of the table and the book. This is sometimes referred to as a normal force. This force pushes upward on the book. Since these two forces are of equal magnitude and in opposite directions, they balance each other. And so the book does not move or it stays at rest. When the forces on an object are equal and in opposite directions, the forces are said to be balanced. What is the net force if the forces are balanced? Net force is the sum of all forces acting on an object. So if the forces are balanced, then the net force is equal to 0 because the forces cancel out each other. Considering our example, what is the net force acting on the book at rest on the table? Since the force of gravity and the normal force are equal in magnitude and in opposite directions, they cancel each other. Thus, the net force on the book is equal to 0. So when the forces on an object are equal in opposite directions, the forces are balanced. The forces acting on a stationary object are balanced, so the object stays at rest. And when the forces are balanced, the net force is equal to 0. Thus, there is no net force acting on an object at rest, since the forces acting on object at rest are balanced and cancel out each other. Let's consider another example involving balanced forces. Hanging a pen by a string. The pen is at rest, implying that the forces acting on it are balanced. What are these forces? 1. The gravity pulls the pen downward. The other force is the string pulls the pen upward. This force, or this upward force exerted by the string, is also referred to as the tension force. Since the force of gravity on the pen and the tension force are equal in magnitude and in opposite direction, they cancel out each other. The two forces balance each other. Thus, there is no net force acting on the pen, and so the pen stays at rest. In both cases, the book resting on tabletop and pen hanging by a string, the forces are balanced. The motion of the objects did not change. The book and the pen stayed at rest and did not move. But what if we cut the string? Yes, the pen falls. Why? Because there is no more force acting on it to counteract the pull of gravity. Are the forces still balanced? No, the forces are no longer balanced. We say that the forces are unbalanced. And so, the net force is not zero because the forces do not cancel out each other. When the forces are unbalanced, that means there is a net force acting on an object. The net force or an unbalanced force causes the pen's state of motion to change. The pen, initially at rest, it starts to move downward because there is an unbalanced force acting on it. Let's go back to our example about the book resting on the table. The forces acting on the book are balanced, so it stays at rest. So what do we need to do to move the book? Yes, one way is to push the book in one direction. Why would the book move this time? Because the forces acting on it are no longer balanced. Or in other words, a net force acts on the book. And the book moves in the direction of the unbalanced or net force. So, an unbalanced force or net force causes an object at rest to start to move. Now let's consider the forces on moving objects. What happens when a moving object is acted upon by balanced and unbalanced forces? When the forces acting on moving object are balanced, the motion of the object does not change. That means the object moves with constant velocity or with constant speed in a straight path. So if an object is moving with constant speed and direction or constant velocity, then the forces acting on it are balanced. Now, what happens to the object's state of motion when unbalanced forces act on it? Unbalanced forces change the state of motion of an object by one of these three ways. 1. Unbalanced force may change the speed of an object. The object may slow down or speed up when unbalanced force or net force acts on it. Unbalanced forces may change the direction of the object's motion. Or unbalanced forces may change both the speed and direction of an object. In other words, unbalanced force or net force causes the object to accelerate. Or when an object is accelerating, it means that there is a net force or an unbalanced force acting on it. So let's summarize what we have just discussed. The forces acting on the objects are balanced when they cancel each other, while unbalanced forces do not cancel each other out. When the forces acting on a stationary object are balanced, the object stays at rest. While when the forces are unbalanced, the object moves in the direction of greater force. But when balanced forces act on moving object, the object continues to move in the same speed and direction. That means constant velocity. But if the forces are unbalanced, the object changes speed or direction. Or in other words, the object accelerates. Thus, balanced forces do not change the state of motion of an object, whereas unbalanced forces change the state of motion of an object. For balanced forces, the net force is equal to zero, but when the forces are unbalanced, the net force is non-zero. That means there is a net force acting on an object. That ends our lesson today. Thank you so much for watching. Bye-bye!